All right, in this video, we're going to look at how we can take a binary number and convert it directly to its decimal equivalent. So, for example, what I'm saying is, let's suppose I had the binary number 1101101, and I wanted to turn this into its decimal equivalent, right? I want to be able to, I don't want to have to like count in binary all the way here to find out what it is. So there should be some algorithm that I can use to do a conversion. But before I do that, I'll just set that aside. And what I want to do is, let's go back to decimal again, because we're familiar with it, and look for a pattern that can be helpful. So I'm going to take the number. So here's my decimal number. And I'm going to take the number 5, 9, 3, 7. And when we look at that number, right, we know that this 5 here doesn't represent 5 things. It actually represents 5,000 things. And this 9 here actually is 900 things. And that 3 is 30 things. And then the 7 is 7 things. So what I can do is I can take that decimal number and I can express it as a sum, right? Because the place value is important here. And then I have another pattern happening, right? If you look, I've got 3 zeros, then 2 zeros, then 1 0, and then no zeros. And what I'm noticing is that I've got powers of tens. So for example, this, instead of expressing it as 5,000, I could say it is 5 times 10 to the third power. And this will be 9 times 10 squared, right? Because 10 squared is 100. And 3 times 10 to the first power, right? 3 times 10 is 10. And then this is 7 times 10. I want to continue the pattern here. So it's 10, right? 3, 2, 1, 10 to the 0th power. And remember, anything to the 0th power is 1, so 7 times 1 is 7. And actually, if you haven't really thought about it before, right, we all know that anything to the 0th power is 1. And if you look at this pattern, you can see why it actually has to be. Okay? So now, when we're looking at this pattern, all right, let's break down each individual term. So in every single term, right, we've got the digit, which is just the symbol that you see in the number. And then there's the base. And the base is just the number of symbols that there are in the counting system you're using. So in the decimal system, we have the digits 0 through 9, which is 10 unique symbols to represent stuff. And that's why it's called base 10. And then up here we have the power, right? And the power is related to like the place value. Okay? So you could take any decimal number, and instead of just writing out the number, we could express it as a sum of numbers multiplied by powers of 10. Okay? So I'm going to leave this, try to keep this in the frame a little bit here. And I'm going to go back to our binary example, right? So when we look at this, right, I still have the same, like I'm going to take each different term, and I still have the same place value power. Like this would be the 0, the 1, the 2, the 3, the 4, and the 5. So in this case right here, right, the digit I see is a 1, and I'm in the binary system, so I have two numbers to represent, two symbols to represent amounts of stuff. So I'm in base 2, and I'm in the 5th position. And then I continue. So the digit I see here is a 1 times 2, because I'm in base 2, to the 4th. And then I have a 0 times 2 to the 3rd. And I have a 1 times 2 squared. And I have a 0 times 2 to the 1st. And I have a 1 times 2 to the 0th power. Okay, so same pattern. Digit times the base that you're in, times or raised to an exponent that is related to the place value of the number. right? So now I can just simplify this expression. So I've got 2 to the 5th, which is 32, times 1, still 32. 2 to the 4th is 16, times 1 is 16. 2 to the 3rd is 8, but times 0, so it's 0. 2 squared is 4, times 1 is 4. 2 to the 1st is 2, but we're multiplying it by 0, so it goes back to 0, right? So the ones with the 0 don't contribute to the sum at all. And then 1 times, and then I've got 2 to the 0th, which is 1, right, times 1, which is 1. If you're going to make a mistake in here, there are 2 mistakes that happens. One is forgetting that you start counting your place value at 0, and then the other is forgetting that anything to the 0th power is 1. All right, so I can just go add these numbers up now. And 32 plus 16 is 48, plus 4 is 52, plus 1 more is 53, right? So 110101 would be the binary representation of the decimal number 53. So let me try one more, just so you can see one more here. And this time I'll try, say 10110, try a shorter one. And I'm going to try to show a little less work this time, right? So remember, our place values are 0, 1, 2, 3, 4, right? So this is 1 times 2 to the 4th, but really, I don't need to write the 1 times, right? Because multiplying something by 1 doesn't change its value. So this is a 2 to the 4th. And this is 0 times 2 to the 3rd. And since I'm multiplying 2 to the 3rd by 0, this doesn't contribute to the sum anyway. So I really don't need to even write it down. And then this is 0, 1, 2. That's a 2 to the 2 to the 2nd. Because there's a 1 there, it does contribute to the sum. So that's 2 squared. And then I have a 2 to the 1st right here. And then I have 0 times 2 to the 0th. So I don't have any, the 2 to the 0th column digit doesn't contribute to the sum, so I don't need to write it down. And so here I have 16 plus 4 plus 2, and 16 plus 4 is 20 plus 2, and it's 22. So the reason here I wrote out the full expansion is really just because I wanted you to see that we're still doing that same pattern of the symbol times a base raised to a power, the exact same pattern that we do in the decimal system. But it turns out the conversions are actually much easier in binary, because all you have to do is, if it's a 1, then that power contributes to the sum, and if there's a 0, it doesn't, so you can just skip that term. All right? So I'll show 2 more examples, but what I want to do this time is just give you a little bit of time to try it. So let's try. Here's example number 1. I'm going to do 1, 1, 1, 2, 3 zeros, a 1 and a 0. And I'll do another one, and I'll just do, how about straight ones? 1, 2, 3, 4, 5 ones. And pause the video. Try working these out on a piece of scratch paper. And then in a few seconds, I'll do the work so you can check your answers. But again, don't just watch the end of this video. Actually pause the video, try it, see if you can do it by yourself before you watch the rest. All right, hopefully you actually pause the video. So let's do this, and we'll try to do it as quickly as we can. So let's see, the place values are 0, 1, 2, 3, 4, 5, 6. So that means there's a 2 to the 6th. That's a 2 to the 5th. 0, 1, and a 2 to the 1st. So that 2 to the 6th is 64, plus 32, plus 2. So we've got 96 plus 2, and that's 98. And hopefully that's the same number you got. And we'll take this one here. and it's 0, 1, 2, 3, 4. So we've got a 2 to the fourth, plus a 2 to the third, plus that's a 2 squared. And that one's a 2 to the first, and that one's a 2 to the 0. And let's work them all out. So I got 16 plus 8 plus 4 plus 2, and 2 to the 0th is 1. So we got 24 plus 4 is 28, plus 2 is 30, plus 1 more is 31, right? So 98 and 31 are the answers. Hopefully that's what you got. And thank you for watching.